Let's go over some other functions now. First off, the choose function. The choose function is ideal for converting a value into a literal. In plain speak, this means turning a number such as 4 into a word, such as April. Choose takes up to 30 arguments. This first argument acts as a key to the rest of the arguments. In fact, the other arguments do not get processed per se by the function. Instead, the function looks at the value of the first argument and based on that value returns one of its other arguments. The first argument must be or evaluate to a number. This number, in turn, indicates which of the following arguments to return. For example, the following arguments 2 equals choose. So the first argument is the number 2. So I will type this for you so you can see what I'm talking about. Let's do this. 2. And we will be choosing 1, 2, 3, 4, 5, 6 arguments. Okay. And this should be, oh no, wrong. 1, 2, 3, 4. Yeah, that should be fine. Okay. Great. And we'll finish this with 1, 2, 3, 4, 5. Okay. So, the first argument is the number 2. This means that the function will return the second in the list of arguments, following the first argument. But watch out, this is not the same as returning the second argument. It means to return the second argument, not counting the first one. What do we mean by this? Choose is most often used to return meaningful text that relates to a number, such as returning the name of a month from its numeric value. But choose is not restricted to returning text strings. You can use it to return numbers. So basically, if we would have like 12 months over here, it would be from January to December, and you would have a date division, so it would be like the second, the 5th month, let's say, so it would be May. So in here you would basically see another number, but a word. So let's input a word, so word, and it tells, it intercepts the word. So basically, if you have a very long script or a table of values, you can input the answer really quickly for a huge amount of data. Okay, so let's move on to logic, to a bit more of logic. I'll mark this. Okay, and this was the choose function. Next, we go on to the logical functions. So, we have to do some logical functions, so we will begin with explaining them. Let's begin with the not function. As I said, these are logical and widely used in programming or in math operations. So, not is a logical operator. It is used to reverse a logical value, turning true to false or false to true. So, what will happen by just inputting not? So, 1 is higher than the 70. Oh yeah, that's an error. So let's say this one is bigger than this one. Well, this is obviously true. Sorry, this is obviously wrong. Now this is obviously true. 4 is smaller than 5. So the answer would be true for any other function, but here you have a false. Why is that? Well, because this is a basic negation. This argument tells the function to override the false and override the true and write in false, and this overrides everything that you choose it to. So basically, if you want to counter a logical word from true to false, this is where you do it. Okay, let's move over to two other functions, which are and or. Just imagine right now how many variations of data you could use just by combining if with not and choose. And now I will explain two more, which are also pretty amazing functions for you. And or both return a single logical answer, either true or false, based on the values of two or more logical tests, such as the way if works. The AND function returns true if all tests are true. Otherwise, false is the return. So basically, if let's say 5 arguments are true, then it returns true. But if any of them is false, then it returns false. The OR function returns true if any one or more of the test is true. Otherwise, false is returned. So OR works like this, that if any argument in the logical arguments table is true, then it works as true. It's basically it's based on the word or. So if this is true, or this is true, or this is true, or this is true, it basically says then true. With AND, if this and this and this and this and this and this is true, then return true. That's basically what it does. It's really easy. So let's begin with the OR function. Equals OR. And we have a few logical arguments. So let's say this equals this equals this, and this being bigger than this. So what do you expect to happen? Well, this is pretty obvious. It should be true. Let's see what happens. Great, it's true, because the last function, the last function is actually true in the OR function. So the E13, which is 5, is bigger than 4. In any other case, it's plainly wrong. But if we change the mark to smaller, we will see that it's false because everything in it is false. So let's return a true value. Okay. AND function equals and. Okay, so let's do some logical work. This one equals this one. This one is smaller than this one, and this one is bigger than this one. So what do you expect to happen? Yeah, it will shout false because of the first function. How so? Well, E11 is not equal to E12, so this is false. So if we change this mark to bigger than, yeah, it still is false. We still have a logical error somewhere. Let's search for it. So E11, which is over here, is bigger than E12. Yeah, that's wrong, because it's not, it's smaller. And the rest should be fine now. Yeah, and now it's true. So next off we have the XOR function. So OR previously returns true when at least one condition is true. This makes sense considering it's the word OR, as in this or that. So what does XOR mean? In logic speaking, XOR is an acronym for exclusive OR. With a given set of conditions, XOR returns false if all the conditions are true. This can be confusing. Please don't shoot me. I'm just the messenger. Seriously, you really must wonder what is going on here. I have always found the best way to think of XOR is that it does the opposite of OR. In other words, if only one condition needs to be true in an OR test to have it return true, when if only one condition in an XOR test is true, it returns false. Believe it or not, there are useful applications for this. So basically, to do the XOR function, let's maybe go over it over here. We'll do a small table. Before, now the yellow marking. Great. Now let's go to help for the XOR function, because there is a very useful tip in there. Great, we have the XOR. Okay, help with this function. And let's go over the example that is given in the help over here. Let's zoom in. So, we have the exclusive OR shown as over here, and it has actually two different functions given below. So, we have the exclusive OR because one of two tests evaluated to true is returned. This is actually true. So because one of the two tests evaluates to true is returned. Oh, and over here we have because all tests evaluate to false is returned. At least one of the test results must evaluate to true to return true. So at least one of these is true. So basically 12.4 is not is definitely not bigger. Sorry, is is bigger than 6, but 3 is definitely not bigger than 12.4. And over here we have 3 bigger than 02 and 9 bigger than 02. So basically both of them are true. So because one of these tests evaluates to true is returned. That's basically what it is telling us. And over here, because all tests evaluate to false is returned. Yeah, so let's do a equation to tell you how it works. We'll have the XOR function. Oh, sorry, equals XOR. Returns a logical one. So we will input three obvious functions. The 10 equals 10. Second one is 1 equals 1. And third one is 1 equals 1. This will be obviously, all three are true, yeah? So the function is true, that's obvious. But what will happen if I'll type in 1 equals 2? It shouts out false. Because we have two true functions and one false. So basically it tells us that this is the opposite to OR. So let's change this one also to 1 equals 2. It shouts out true. That being because only one function is true and two functions are false, it shouts out true. So this is basically it. This is basically how XOR works. And how to use it in real life. Well, imagine situations like this. A situation like this, you have a percentage of revenue change by month, and you have 3 years, 2011, 12, 13, and you have the question if the revenue in each month every year, so January 2011, January 2012, and January 2013, has the higher or smaller revenue depending on the year. So let's say first year you have 10, second year you have 12, and third year you have 15. And the question is it always bigger? Is it always bigger than it was previously? So it would be false this time. So basically this is how it works. Just to use it, you can figure out the details on your own. As I said, I will not be going over the logical details here because it will just take us way too much time. Okay, finding where it is. Let's go over the address function. So The address function takes a row number and a column number as arguments and returns a standard cell reference, cell address. For example, if you pass the row number 4 and the column number 3, the function returns C4. Address can return an obsolete or relative reference in either of Excel's two reference formats. Before getting to the details, review the differences between absolute and relative cell references. So a relative reference is expressed as just the column letter and row number. Well, for example, A100. When you copy a formula that contains a relative cell reference, the reference, the row number, and the column letter is adjusted to reflect the location in which you copied the formula. An obsolete reference has a $sign in front of the column letter and row number. For example, $sign A, $sign 100. When you copy a formula that contains an obsolete cell reference, the reference does not change. Next off, a partial obsolete reference has a $sign in front of the column letter or the row number. For example, $sign A100 or A $sign 100. When you copy a formula that contains a partial obsolete cell reference, the part of the reference with the $sign does not change, but the other part does. So let's go over the address just to see how it works. So you type in equals address function, and now you see we have the row number, column number, absolute number, absolute A1 function, and the sheet text. So how does it work? So in the two tables I'm showing you right now, we see a worksheet in which entering a formula with a completely relative cell reference causes a problem. Totals are the result of adding the tax to the amount. The tax is a percentage, which we can see over here, for a 7.5% tax rate. Let's maybe change this to the tax rate so you can see what I'm talking about. Yes, exactly. This percentage is in the cell D21 and is referred by the formulas. The first formula that was entered is in cell D25, so you can see it over here. So how does this formula work? It's basically a multiplication of the cell C25 by adding 1 to the percentage of 7.5%. Well, the formula here works correctly. It refers to this, to the percentage cell and to the amount cell. But if you use the fill handle to copy the formula from cell C7 to cell, from cell D25 to any other cell, there's a problem. The reference to cell D25 changes. To cell, let's say, if I would copy it over here, if I copy it here to here, you can see it being changed to cell E21. So basically, it's impossible to copy the value in this cell to have a proper result anywhere else. See, the reference changes by the movement you make by copying the cell itself. Okay, let's erase this area. Where is it? Yeah, no problem. Okay, great. So, what can we do to avoid a situation like this? So the answer to your question would be use an obsolete cell. Here you have the typical cell numbers, and if we drag and drop them like this, they will show errors, because as you can see the D stays because we are still working in the column D, but the number of the rows changes depending on where you move. You see D20, 30T, 3D, 24, and etc. So The way to avoid this is using the obsolete cell. So first off, just to show you, we will use the obsolete number of the row, which is D21. So let's copy this one anywhere in our row. Okay, great. And observe over here. The D21 is still the same over here, and over here. Of course, the column will change depending on to which column you go, because the only obsolete part we made is the column number, not the row number. Sorry, the row number, not the column number. So D changed to C, and etc. So to use the obsolete number properly, you would have to use it in this function actually 3 times. So let's go over here and use the obsolete number, and also over here and over here. So number doesn't change at all, but right now if we copy it anywhere else, see what happens? The value is still the same. So basically that's how the obsolete value works. So now let's go back to the address function, and it takes up to 5 arguments, as I said before. Okay, so the row number of the reference, the column number of the reference, a number that tells the function how to return the reference. The default is 1, but can be 1 for full obsolete, 2 for obsolete row and relative column, 3 for relative row and obsolete column, and 4 for full relative. So let's go over some examples. First off, we input the address function. Okay, what would happen if I inputted 5#2 and close it like this? Well, the result would be $B $5. Only the column and the row are provided as arguments. The function returns a full obsolete address. Exactly. Next off, let's say you put in the address 5#2#1. So you can see that actually Excel shows after the absolute number the 4 uses you can input. So we input 1. So the answer would be still the same. When a 1 is issued for the third argument, a full obsolete address is returned. This is the same as leaving out the third argument. Great. Now let's maybe use the same function, but with number 2. What will happen right now? Well, we will have B $5, because when a 2 is used for the third argument, a mixed reference is returned, with the column relative and the row obsolete. Great. Now let's see what happens if we change it to number 3. So when a 3 is used for the third argument, a mixed reference is returned with the column obsolete and the row relative. So we have the opposite work we have over here. Next off, let's use 4. When 4 is used for the third argument, a full relative reference is returned. So basically we have it without the $signs. So what happens if we use a 4th argument with number 1 at the beginning? What happens? Let's use 0. You can see it having 2 possibilities, 0 or 1. So when the 4th argument is false, an R1 C1 style reference is returned. So you can see it shown over here. And next off we have the possibility, let's change this to 3 and use a 0 argument still. So we have this answer, and this example tells the function to return a mixed reference in the R1 C1 style. Next off, well, let's maybe use well, I'll use this as the last example. Let's leave the fourth argument blank, and input we don't have. Maybe let's input the English sheet. Okay, let's see what will Excel do if I try to input sheet 2. So what it does is the fifth argument returns a reference to a worksheet or external workbook. This returns an A1 style reference to cell B5 on sheet 4. Okay, let's leave it at this. Basically, the address function is very useful while you want to have a number of arguments. So instead of directly entering a row number and column number into address, you can either enter you can enter cell references. However, the values you find in those cells must evaluate to numbers that can be used as row numbers and column numbers. So that's basically it for this function, and actually lesson 10. What I want you to do is use the XOR function, the relative address. Please use the relative address a few times just to see how much easier it would make your life if you had a huge table of data and would have to copy some of it, and you really didn't want to change the cell or the row of the address. You can always use the relative and obsolete addresses for your cells. Next off, I want you to use the address function for your own. And basically, if you want any more explanations regarding this function, remember you always can use the help in Excel. It is very useful. It has many examples and it will tell you a lot about the function itself. So if you still don't understand this function, read this. This will probably answer all of your questions. Okay, great. So thank you very much for sticking with me until lesson 10, and I hope to see you in lesson 11. Bye.